Everybody should mute, please. Dr. Sebastian, you can mute. Yes. So we now say that the ratio scale has all the attributes of nominal, ordinal, and interval, and something in addition, and that is the true zero origin. So most of the attributes we measure, especially that are quantitative, they have this true zero origin. So if you look at it now, every attribute, most of them, so the only one that is not yet centigrade and Fahrenheit, they are interval because they don't have true zero origin. But talk about weight, blood sugar, temperature in Kelvin, which is thermodynamic scale, all of them have true zero origin. If the attribute is not there, it will read zero. If it reads zero, it means the attribute is not there. So you will see that from this, you know that the first two, nominal and ordinal, appear to be applicable to categorical variable. You know, the categorical variable we talk about, that they don't actually have number as value originally, while the scale, the interval and ratio are numerical variable. So let's now go back to our classification. You see now, it make it easy. So under the categorical, which is qualitative, we have nominal or ordinal. Those examples, we have talked about them. See, sex, male, female, blood group A, B, B, O. Then ordinal, we see disease stage, mild, moderate, severe. Then the quantitative in the numerical, you will be expecting to see, is it interval or ratio? No. So you will see quantitative, we have discrete and continuous. So this numerical, this quantitative, there are two possible ways. It's either the number can have decimal, you know, or its whole number, which is called integer. The whole number cannot have decimal. So in that situation, if you look at it, when you are counting something, it can only be whole number. Number of children. You cannot also have number of children in your family, say 2.5. No, it's either 1, 2, 3, whole number. Number of people in the class, usually a whole number. Number of something. But when it comes to age, blood sugar, it can have decimal. So it's continuous. So another way of looking at it is that this discrete is counted, this continuous is measured. Another way of looking at it is that in between two given value, the discrete has limited number of value. For example, in between 1 and 5, how many values you have? You have 1, 2, 3, 4, 5. You have limited number of value, given value. But if they say blood sugar between 60 and 65, will you say it's 60, 61, 62, 65? No. In between 60 and 61, you can have 61, 60.112, 60.113, 60.104, you know, infinite number of value in between two given value. So whenever something can have decimal, so in between two given value, there are infinite number of possible value. So continuous variable are those ones that, like for weight, height. Forget that when we measure, we try to approximate. Most of the time, we measure weight. When you say somebody weighs 70 kg, it may be 70 kg, 200 grams, 30 microgram. But you know, within the limit of error, you try to approximate. That's why it look as if they are whole number. They are not actually whole number. They can zoom that something, what do I call it? Decimal. Now, let's move further. There's another way. You know, I've already said this way of classifying variable and data is just so fundamental in the sense that it's just okay. We say variable value of variable are data. And if it can assume that type of value you assume is number, is quantitative. If it is quality is not number, it's categorical. You know, you can see it's so simple, so straightforward. But it doesn't make statistical sense like this alternative classification. There's a way you can classify variable. You can just say variable is either discrete or continuous. You know, the word discrete means that there are distinct categories. That's the meaning of discrete. Distinct category. You know that nominal, they have distinct category. When you say nominal, it may be for sex, now either male or female. For ordinal, it's the same thing. So that nominal, ordinal, they are actually, you can classify them as discrete also. The only difference between that one and the discrete we talk about here is that this discrete is numerical. And you see, that's why I call numerical here. So that discrete you see in this first slide is what I now call under discrete numerical. When you say number of children, because you is discrete, because in between two values, you have distinct category. You can see these are the number of children we have in between 1 and 2. It's the same thing when we talk about nominal. If it's sex, 2 category. If it's something that maybe 5 category, they are distinct. The same thing with ordinal. It's only that the difference between ordinal and nominal is that ordinal there is element of more than or less than. So both nominal, ordinal, and what we call discrete here, they are actually discrete, while the other one continuous. So you get to understand better that when, number one, when we want to summarize, how do we summarize variable? How do we present distribution? You go to see that whether with the graphical method, go to know there are some graphical methods used for discrete, some for continuous. When we come to probability distribution, there are discrete probability distribution, continuous probability distribution. So you're going to see that this one makes more statistical sense, but it may be a little bit difficult to conceptualize. But while the other, this first one is easy to conceptualize, but it's just for explanation for people to get the initial explanation. But this is the one that makes sense as you are advancing in statistics. Now, concerning measurement, this one is just how to get data, measurement. Measurement and observation is actually the same thing in statistics and research. When we say measurement and observation is data collection, that's all. But you know that when we want to collect data, I think I made mention of that even in the previous lecture. When you want to collect your data, there are some things. You see somebody that is female now, you go to sex. You won't say, you see somebody the way he is dressed, you see the face, you cannot be saying, are you a male or female? What is your sex? You better look at you, there's something wrong with you. You just take female because you already know. Unless if you meet a transgender person that you are even confused and you don't know. And gender is different from sex. So sex is biology. Gender is social role. Because somebody that is a gay now, it may be a wife of somebody. When he's out of gender, it's female. While somebody that is a lesbian may be the husband in the relationship. When you talk about gender, it says male. It's not, that one is different. We're talking of sex now as biology. So by looking at the person, you say this one is male, this one female. You just by in color you are looking at, you don't need to, you've seen the person, oh, this one is male. Somebody is mute, you can mute yourself as you come in. So you can say, okay, this one is yellow, this light in complexion, this dark, But there are some things you need to ask. If you want to ask for, you may not know the religion, or you may not know the ethnicity, you may not know some other thing. You want to ask question, have you heard of this? Have you heard of tuberculosis? Have you heard of HIV? Or you want to know something that requires yes or no, whatever that the person wants to tell you. Need to tell you for you to now know you've had with your, with your head now, you record. Some you may need to, take measurement as per stand on the weighing scale. You measure the height, you measure the weight. Sometimes you may measure your blood pressure. Even sometimes you may carry out some examination. So whether it is what we call observation or measurement, it just means the same thing. So here now, just okay, how do we get our data? More formally measurement. In a situation where you try to bring some, but sometimes it's something just observation. So all of them, they mean the same thing. So observation are the unit upon which measurement are made. Variable are the characteristics being measured. Value data are realized. Just to summarize that. So I think I've talked about this one. Let's now move to this scale of measurement, parameter and statistics. If you look at parameter and statistic here, the statistic here does not carry S because it's not talking about the subject. Statistics as subject carry S. This one here will not carry S unless it is in plural form. So if it's in a singular form, statistic, does not carry. It's not the subject now. Now, as a, we started with the concept of population. As a researcher, you are interested in something in the population, and that particular variable, attribute, phenomenon is there in your mind. That is the primary outcome. For example, now, when Dr. Ramatu was talking, he said, adherent to antiretroviral drug. So at the end of the day now, maybe adherent, or maybe adherence is good, or maybe, the percentage that have good adherence, maybe 50% or 30% or whatever. That thing exists in the population. The percentage that adherent to this, it exists in the population. Now, if you want to the prevalence of anemia, the prevalence of anemia, maybe among under 5, maybe it's 50% or maybe 30% of the under 5 in the rural community is anemic. It do exist there, but because you, as a researcher, most of the time you cannot attend to all the elements in the population. You take sample. So by the time you summarize using sample, what you get as prevalence is statistic. But the real prevalence in the population is parameter. If you want to measure weight, the mean weight in your sample is statistic. The real mean weight in the population is parameter. And you only got, most of the time, it's only God that knows the parameter, because for you to actually know the parameter, unless you consider all the elements in the population and carry out your observation, and before you calculate. If you can measure, like for example, the whole of Abuja or Lagos now, if you can measure all the adults and measure and calculate their mean weight, that would be parameter for Lagos. That is what is the mean weight in Lagos for adults. But it's not possible. You take sample. If from your sample, maybe 800 people or whatever, or even if it is 1,000, 2,000, whatever value, since it's not the whole population, you now calculate the mean weight. That mean is statistic. Why the